And in this video, we're going to be looking at another interview question that's commonly asked. And this one is removing duplicates from sorted array, second variation. Okay, so basically, we looked at one of the similar question where we were removing duplicates in place from the array. Now, this time it's a little bit more complex because what the interviewer is asking is to basically have duplicates up to basically twice. Okay, so you can have, for example, if let's take a look at the example and you're going to understand it better. If you have this array where one is repeated three times and then two is repeated two times and three is repeated one time. Now, in this case, uh, duplicates can appear twice. Okay, so when you're gonna return your output, basically the output is going to be length 5 because the first five elements of the number are being duplicated. So are being basically being duplicated, but third duplicate is removed. So for example, 1 1 and you get 2 2 and you get 3. So one of the additional one is removed, and that's how you got the length to 5. Okay, let's take a look at another example. So we have 0 0, so it's not going to be replaced. Then we have 1 1 1 1, so four times. So that means like one is only going to appear twice in the final result, and then we can have two. Okay, and then we're gonna have 3 3. So 1 2 3 4 5 6 7 is gonna be the result. So that's what we say. The result is gonna be 7, and the elements are gonna be 0 0 1 1 2 3 and 3. Okay, so that's the question. As you can see, like it's a bit a little bit more tricky. Just to give you a hint, basically, you can leverage a second pointer. You can leverage another variable, another pointer to basically keep track of elements progress. So that's the hint, and most likely when you're like in the interview, your your interviewer is gonna uh, hint you something similar. Okay, the conditions stay same. You can modify the array itself, so you're not gonna create a new array. Although in Swift, because instead of using like basically because like arrays are part as constant, you have either have a choice to basically update the basically create a copy of the array and then update that, or you can supply that as in out variable. So we can actually just create a copy, but consider that that's not going to be questioned during the interview if you do that, because many times most of the iOS developers or Swift developers understand that keeping that let constant that's being passed in is better than passing in and out because it doesn't work out for most of cases. Okay, so with that said, I will say like take a first stab at it. Pause the video here and see if you can actually come up with a solution, and unpause the video later on and to see like what solution we have. So I'm gonna take like just a couple of seconds pause so you can actually pause the video. Okay, so hope that went well. Let's take a look what we have here as a solution. Okay, so like I said, this one is slightly tricky, although solution is not that hard, but it's slightly tricky. So basically, what we're gonna leverage the fact that we can use two pointers to keep track of duplicate values because we have like up to two duplicates that we can keep. So we're gonna keep two pointers, one that's gonna compare the current and previous indexes, that like index that we are actually saving, that we were saving in last remove duplicates. So we are in the last video you're only keeping track of one index. This time, basically the previous index. This time what we're going to do is we're going to start our index from first Uh, uh, Earlier we were starting from zero. This time we're gonna start from first element in the array, and then we're gonna go one back just to say like, hey, go one previous in the index and see what kind of value it had, and only increase basically index when those two values are not zero, and uh, sorry, if those two, like the current index and the previous index, are not equal to each other, and the other condition that's part of OR, you can check if the current pointer in the loop is not equal to the current index. Okay, so those two conditions, if you check, like, and either one of them, if either one of them is true, that means we have to increment our index, and with incremented index, we're gonna replace current, basically, that indexes array item by the current looping item. Okay, so it's better explained when you see the example. That's why we have, like, this example here. So let's take a look at the algorithm first. So we're gonna first say, like, that, hey, if the array count is greater than two, then that's great. Otherwise, return the array count, because we need at least two element to actually work on this. Okay. Next thing is, we're gonna start our index, the extra uh, pointer that we are keeping, with one. Um, and then what we're going to say is loop from to second index. Okay, so we can actually compare. So first index, we can go back in the so if you have the array, we can go back by one index, and that's why we're gonna start from two, and then we're gonna come go up until the one, or basically less than number dot count. So array dot count. That's what we're gonna loop uh, tail. Okay. Now we're gonna compare, like I said, the index and index minus one. So uh, zero, so first location at the array, and zeroth location at the array. Okay, so that's why we are starting from two, so we don't get out of range exception for these. Now we're going to compare these. If these two are not equal, that's good, that we increment this. But if these two are equal, then we check other condition, that is, which is or, actually. So either one of these has to be true. So if we say the current index is not equal to the current looping item, okay? If it's not, then we go again inside and increment the index and replace the value. If none of these are, like, true, basically, or yeah, so if none of these satisfy, then we actually just continue our loop. And like before, we just return index plus one. Okay, so let's take a look at the example, and it's gonna help clear things up. So this is our array: 1 1 1 2 2 3 3. Okay, eventually the output should be 1 1 2 2 3 3, and we discard the last three. Okay, so this 6 is what we return as the length. Okay, so I've just indexed them for, like, a better reference. So 0, 1, these are the index values for these items. So first we say index is 1. Okay, we go inside the for loop. I value is 2. Okay, number at index, so number at 1, basically the array at 1, first element at this first one index is 1, right here. Sorry, this one right here. And 1 minus 1, 0, is also 1. So zeroth index is 1. Okay. Number at I, which is 2, is also 1. So second index is also 1. Okay. So we say if 1 is not equal to 1, um, okay. So basically, index, uh, index and index minus 1, 1 is, and 1 is not equal to 1, so that is false. And we check the index, which is 1, and the current looping element, 1 is not equal to 1. So nothing happens. Basically, these two conditions don't satisfy, so we just skip and we continue. Increment I to 3. Now nums at index is still 1, nums at index minus 1 is still 1, but nums at I, current looping index, current looping item, is has now become 2 because I's value is 3, so this element is 2, so that's why it's 2. Okay, so we compare. 1 is not equal to 1, that is false, so we skip. So not skip. This condition does not satisfy. So we check the OR. 1 is not equal to 2. Okay, so that's actually satisfies. So we go inside. We say increment the index. So index becomes 2. So index becomes 2. And then we say num at 2, basically. So nums at um, second index. Um, so second index becomes 2, which is the current element. Okay, so this 2 jumps over here. So we have 1, 1 right here, 1, 1, 2, 2, 2 is repeated, 3, 3. Okay, so we go on to the next element and we say, like, 4 and index becomes 2. Now we just incremented that. Number at index becomes 2. Number at index minus 1 becomes 1. Okay, and number at 4 becomes 2. So if you look at it, 4 is still 2 right here. So it says 2. Now we check the condition. 2 is not equal to 1. So basically, this one, uh, number at index is not equal to number at index minus 1. So we say increment index. Index becomes 3. Num at 3 is, so let's make sure I reference this one. So num at 3, wait, um, so num at 0, 1, 2, 3 becomes 2, right? Because that's the current element. Yeah, that's right. So it's still 2. So this is like just a override because, like, we have three duplicates here. So it's gonna actually it's going to override the second duplicate as the unique value and then going to loop over. So second index, basically the index after it at 5, where index becomes I equal to 5 and index becomes 3, where all the difference is going to be made. So you have like num set index is 2, num set index minus 1 is 2, and then nums at 5, which is current iterating item, is 3. Okay, so we say 2 is not equal to 2, false, and 2 is not equal to 3. So basically, the the condition that checks out is basically the current no, yeah, current pointer value, current looping value is not equal to current looping index value. Okay, so current looping index value is I, and pointer is pointing at um, this 2 here, index. So these two do not check, so they're not equal. That means it's time to increment our index. Index becomes 4, num at 4. So num at 4 becomes 3, which is the current element. Okay, so 3 hops over. So 1, 1, 2, 2, 3, 3. And that's the result that we skip, that we basically return. Now, there is one more iteration, I is equal to 6, but it's not going to go over because, like, nothing is going to change. So you can try it out, but yeah, that's the entire logic. Take a moment, go over this one more time. Like, if you need a pen and pencil, draw it in there and see if this makes sense. And in the meantime, we're also gonna look at the repel and see how this actually works for us in the code itself. So remove dupes, array of integer, and we return an int. Okay. Now, first thing we check is the length. So we say array.count is less than equal to 2, then return array.count. Okay, we need at least 3 elements. Now, next is we create our array, just Swift specific thing. Then we create our index, initialize it with 1, okay, not 0. Then we loop over I in with starting index as 2 less than array.count. Okay. Now, first thing we check is if the array index, right? Index is not equal to array at index minus 1. So current pointer and pointer and before that are not equal. So if they're equal, then we're gonna have to increment. And the current looping element, so I is not equal to the index, so current pointer. Okay. If any of these two are true, then we say index needs to be incremented by one, and then array at index needs to be replaced by array at looping index I. Okay, and at the end, we are simply going to return index plus one. Okay, and what we're going to do is at each step, we are going to print our array to see how it's being modified. I step I, right? Step is basically where array is being printed. Now let's say print, remove dupes, and we can say 1, 1, 2, 2, 2. So let's take a look at the take this input 1, 1, 1, 2, 2, 3, 3, 1, 1, 1, 2, 2, 3, and 3. Okay, so let's run it, and there we go. So what we get is 6. Okay, why do we get 6? So we have 1, 1, 2, 2, and 3, 3. So 0, 1, 2, 3, 4, 5. Okay, so that's actually the length. Okay, so I think we should, um, this plus one is not going to be there. So that's a correction that's bad on my part. And because we are initializing index from 1, we do not need index plus 1. So the unique value counting up to basically 2 is going to be just the index. So 1, 1, 2, 2, 3, 3. So 0, 1, 2, 3, 4, 5. Wait. Sorry. That is correct. So length is going to be 6. 1, 2, 3, 4, 5, 6. Yeah, length is going to be 6 because it's zero-based index. That was my bad. Getting confused with indexes. Okay, so that is so at step two, as you can see, we had array as 1, 1, 1, 2, 2, 3, 3. Then at step three, basically when i's value was 3, we got 1, 1, 2, 2, 2. So 2 hopped over, and then we have 3, 3. Then when i's value was 4, we had 1, 1, 2, 2, 2, 3, 3, nothing changed. Then we had 1, 1, 2, 2, 3 hopped over to replace that, and then nothing. And then remaining values was 3. Then 6, when i's value was 6, nothing changed. And that's when we actually return our length. Okay, so let's take a look at the other input that was given. So 0, 0, 4 times 1, 1 times 2. So 0, 0, and 4 times 1, and 1 times 2, and 2 times 3. Okay, that's good. So let's take a look. 0, 0, 1, 1, 2, 3, 3, right? So 1, 2, 3, 4, 5, 6, 7. That's correct. So 7 is what we're gonna return, right? So as you can see how just manipulating some pointers, we were able to find a solution. Now, when you're computing time complexity, just remember that this is still O of n, and I would recommend you going into the detail and finding out how it is, how the time complexity of is O of n, Let me know if there is any issue. But yeah, this was the another example for removing duplicate uh, with up to two repeating numbers. Hope you guys enjoyed this video, and I will see you guys in the next video. Thank you.